today is the point gradient formula. Do I have a laptop charger? No. Right, so point gradient formula. And this comes from the formula for gradients, which is what? What's the formula for finding the gradient of a straight line? M for gradient equals? The difference in the y values over the difference in the x values. Now, we use the point gradient formula. I'm just using as many different colours as I possibly can. If we are given M and some points, which we'll call x1, y1. So if we're given a point and the gradient, we can be asked to find the equation of the particular line. Now what we actually do is we rewrite this formula, because when we have an equation of a straight line, we have it in terms of x and y. Now this formula related when we had 2 points. So what we do is we say, well, we've got some arbitrary point. We have some arbitrary point x1, y1 which we have been given, and we're also given the gradient. And we want to find the equation of the line relating y and x. So what we do is we rewrite this formula. Instead of y2, we just call it some point y minus y1 over x minus x1. So it's exactly the same gradient formula, now using general terms for x and y, because we won't know what they are. That's what the rule is going to be. We then rearrange that by multiplying both sides through by x minus x1. Afternoon. So if I multiply both sides by x minus x1, it eradicates it on that side, and that is what's commonly referred to as the point gradient form of the equation of a straight line. I think. You can rearrange it. Yes, I didn't lie. Point gradient formula. It even says so in the textbook, so it must be. So that is the point gradient formula. And that's what we use if we are given a particular point and a gradient. For example, I'm screencasting this so you can... So you're given, say, m equals 2, and the line passes through the point minus 1, 3. So you're asked to find the equation of a straight line that has a gradient 2 and it passes through the point negative 1, 3. This should say to you straight away, use the point gradient form of the straight line. Y minus y1 equals m outside of x minus x1. It's exactly the same thing as I had before, just written around the other way. Substitute in the values you have. Ooh, I'll go green because I can use that. Yeah. So, therefore, y minus y1, what's y1 in this case? 3 equals m, which is 2, outside of x minus x1, which makes it x plus 1. So all we're doing is substituting into the point gradient formula when you're given a gradient and given a point. And we want this in y equals mx plus b form because that tells us the most information about a particular function. Although, and I had this argument with Mr. Gentle a little while ago, if you were asked to find the equation of a straight line that goes through minus 1, 3 with gradient m, and you gave me that as an answer, how many marks do you think you get in the HSC out of 2? No, you get 2, because you're not wrong. Unless it says in simplest possible form, or in y equals mx plus b form, or in general form, that is actually enough of an answer. But for practice, of course, you should rearrange it. So 2x plus 1 plus 3, taking the 3 over at the same time, which gives us y equals plus 2 plus 3, yes. Y equals 2x plus 5 is the equation of that straight line, which we then can sketch. What were the 2 steps for sketching a straight line? What do we need? X and y intercept. So the y-intercept is at what? It is when x equals 0. If it's in this form, you can just read it off. That's a 5. And the x-intercept is when, how do we find the x-intercept? We put y equals 0. So substitute that in, we get 0 equals 2x plus 5, or x equals negative 5 on 2. And the more of these you do, the quicker you'll get at sketching them. Which then, if we draw some axes, and seriously, don't spend ages using rulers and that sort of stuff if you're asked to sketch. It's all about time in HSC. So it goes through negative 5 on 2, which is about there, negative 2.5. And goes through plus 5. Straight line like that. Whoops. And label your equation y equals 2x plus 5. Actually, as a way of making your work easier, it's actually often easier to go, oh, well, yeah, that's about half the distance along the x-axis is along the y-axis. Draw your line and then mark your points. So then you don't have to get your line to go through the points. So if you're given the gradient and a point, you use the point gradient formula to find the equation of the straight line, and then you might be asked to sketch it as well. Everyone's seen that before? Everyone remembers how to do that? Excellent. Which brings us to the second type of example. When else might you be asked to find the equation of a line? What other information might you be given?
You might know 2 points lie along the line.
Yeah, so if you have 2 points, what's the additional step we're going to have to do? Find the gradient first. And then, after we've found the gradient, what will we do? Use point gradient formula. And that's invariably the sort of question that you'll be asked. Because if I ask you that sort of question, I'm testing you know how to find the gradient, and then I'm testing you know how to apply the point gradient formula, and then I'd ask you to sketch it at the end. So I can cover 3 parts of what you need to be able to do in the one question. So for example, we want to find the equation of the line through 3, 5, and negative 1, negative 4. So we're given 2 points and we're asked to find the equation of the line that goes through those 2 points. Because how many lines can I draw through 2 points? 1. So you must have 2 points to find the line. First step is to find the gradient. Difference in the y's. If you are still not comfortable with remembering the formula, write the formula out, but I don't expect you to. Okay? Difference in the y's, so 5, take away negative 4 is 5 plus 4, which is 9. And the difference in the x's, which is 3, take away negative 1, which is 4. Horrible fractions. The other thing you'll find in HSC is they don't tend to give you horrible fractions. Right. So we've got a gradient, and now we have 2 points and a gradient. Which point do I use? One of them, it doesn't matter. Use the positive one. Why would you use the positive one? Less chance of making a mistake, yeah. So, using the point gradient formula, y minus y1, so we're going to call 3, 5 the point we use. Y minus 5 equals 9 on 4, x minus 3, which is lovely. So, we might just take this a little bit slow because it's got a fraction in it. Y take 5 is 9 on 4 x minus 27 on 4. And then all those people that hate fractions will freak out with this next step. I need to take away, add 5 to both sides, which is the same as adding what on 4? 20 on 4. So y is 9 on 4x. Add 20 on 4 to 27 on 4 is minus 7 on 4. So y equals 9 on 4x minus 7 on 4. And once again, I could ask you to sketch that. The y-intercept is minus 7 on 4. The x-intercept we have to figure out, and we don't need to go there right now.
You could have just sketched it with actual points they gave you in the first place.
You could. Although you have to, when you sketch a straight line, you have to label
The intercepts.
the intercept. So you're still going to have to find the x-intercept anyway.
Just extend the line as far as you need to.
Sorry? What was that?
Extend the line. Do you find it?
What, you're going to draw it that accurately that you're going to use graphical methods for solving things?
Yeah.
No. You'll notice in the textbook that they've got a couple of different formulas, and they've got the 2-point formula, and then they have some weird and wacky intercept formula, which if you want to, you can use, and if you want to remember lots of formulas, that's fine. But to do anything with straight lines and sketching and finding the equations of straight lines, that's all you need to be able to do. So if you have 1 point in the gradient, use the point gradient formula. If you have 2 points, then find the gradient and use the point gradient formula. I believe in not trying to introduce lots and lots of different formulas, because if you do, chance of remembering it is less, yeah? So have a look and see the 2-point formula and the intercept formula in your book, but my recommendation would be this gives you everything you need to be able to do. There's only one other thing we need to cover today, and that's lines that are... So if I've got my axis, we've got 2 special types of lines. Well, there are 3. There are the ones that go through the origin, which we talked about yesterday. And then there are those that are parallel to the x-axis. I should really label my axes, I guess. There are these that are parallel to the x-axis. And let's say they go through a point y equals a. What's the equation of a line that is parallel to the x-axis through a?
Y equals A.
Y equals a. Because it doesn't depend on the x value. Y is always the same thing. Likewise, if we have a line that's parallel, let's call it B for argument's sake. If we have a line that is parallel to the y-axis, what is the equation of a line that's parallel to the y-axis?
X equals B.
X equals B.
Oh my God.
You do need to remember that, because often they will bring those in and people start trying to sketch them using intercepts and they get all freaked out and it just doesn't work. So there are 2 special types of lines you need to remember. Incidentally, what is the gradient of the line y equals B? A, sorry. The line y equals A. What's the gradient of that?
Undefined.
Undefined. Who's undefined? Who reckons it's undefined? Hands up. Come on, vote. Who reckons it's something different?
0.
What is it?
0.
0? Who reckons it's 0? Brock? Yeah, right. Daniel, because you sit next to Brock and Isabel, yeah. Who reckons it's something different?
Undefined.
So this line that is y equals A, what's the gradient of that? 0. Doesn't rise, and it just continually runs. What's the gradient of the line x equals b?
Undefined.
Undefined. Why? Because it's something over 0, which is probably what you were mumbling. Yeah. Okay? So all these things tie together, and you need to be able to do it. Is that fairly clear for everyone?
Yeah.
Everyone's cool with that? So this is fun. Point gradient formula. When you're given a point and a gradient, you use the point gradient formula, although you tend to use it in this way. And if you are given 2 points, find the gradient and then apply the point gradient formula. And just those 2 types of lines.